Good afternoon. My name is Vaibhavi Lineswala, lecturer, Sri KJ Polytechnic. Today's our topic for discussion is transistors. So, our target audience is Diploma Electrical Semester 3 students, and the topic comes under the subject Electronic Component and Circuits, which is of Semester 3. Now, what are the learning outcomes for today's session? So, after this session, you will be able to explain the structure of transistors, explain biasing of transistors, and state applications of transistors. Let us start with the introduction. So, what is transistor? Transistor is an important semiconductor device used in amplifiers, oscillators, ICs, and as a switch. It is a 2-junction, 3-layer, 3-terminal semiconductor device. What is the construction of transistor? N or P type semiconductor is sandwiched between 2 P or N type semiconductors respectively. So hence, you can see there are 2 PN junctions forming, which are called bipolar junction transistor. So hence, 2 type of transistors are constructed, NPN and PNP type of transistor. Also, transistor is classified based on the semiconductor material used, that is germanium and silicon transistor. Now let's see the construction of NPN transistor. You can see construction and symbol in the figure. Here you can see that P region is sandwiched between 2 N regions, and in the symbol you can see the arrow is there on the emitter terminal, which shows the direction of current. Here the current flows from base to emitter, that's why the arrow is pointing outside. Second one is PNP transistor. Again, the construction and symbol is shown in figure. Here you can see that N region is sandwiched between 2 P regions, and the current is flowing from emitter to base, hence the arrow on the emitter is pointing inside. Transistor terminals. There are 3 terminals taken from each layer, namely base, emitter and collector. Now you can see that three terminals are different. Base is very thin and lightly doped, means the amount of impurity is very less in base. Emitter terminal is moderate in size and heavily doped, while the collector terminal is larger than emitter and moderately doped. There are 2 methods of construction of transistor. First one is alloy junction transistor and second one is silicon planar method. These are different transistors available in the market. You can see there are 3 terminals, and some has heat sink on it, some are circular in shape, some are semicircle in shape. Now what is the biasing of transistor? So basically there are 2 junctions of transistor. First one is emitter base junction, which is also known as emitter junction, and second one is collector base junction, also known as collector junction. So to bring the transistor into action, DC supply is given, that is called the biasing of transistor. For that, emitter base junction must be forward biased and collector base junction must be reverse biased. These are the biasing methods for NPN transistor. You can see in the figure, we have to forward bias the emitter base junction, and for that emitter is connected to the negative terminal and base is connected to the positive terminal of the battery. While to reverse bias the collector base junction, collector is connected to the positive terminal and base is connected to the negative terminal of the battery. So these are the necessary conditions for biasing. This is the biasing of a PNP transistor. To forward bias emitter base junction, here the emitter is connected to the positive terminal and base to the negative terminal of the battery. While to reverse bias collector base junction, collector is connected to negative terminal and base to the positive terminal of the battery. Now what are the applications of transistor? As I mentioned earlier, transistors are used as an amplifier, it can be used as an electronic switch, it can be used in oscillators, and it can be used in integrated circuits. Summary. From this session, what we have learned? We have learned about transistor construction, its biasing and its applications. These are some YouTube video link and Wikimedia video link. From that You can refer more about transistors. Thank you.